All right, so let's keep practicing. We have x squared times y to the 1/2 equals 6x plus 5y cubed. Okay, so on this side, we're going to have to do product rule. On this side, I can just go term by term. Okay, so we're going to start off with product rule. I'm going to recognize that this is the first term and this is the second term. And remember that anytime you take the derivative of a variable, you need to multiply it by dx or dy. So I've got the first, which is x squared, okay, times the derivative of the second, which is 1/2 y to the negative 1/2 dy. Okay, so first times the derivative of the second plus the second, which is y to the 1/2, times the derivative of the first, which is 2x dx. So the left side is done. Now I got to do the right side. So I've got equals, the derivative of 6x is 6 dx. And the derivative of 5y cubed is 15y squared dy. Someday I will learn to start writing over here. All right. So if it's got a dx, I want it on the right. So he needs to move. Okay. If it's got a dy, I want it on the left. So he's got to move. So this is going to stay here. Okay. So he is an x, or a 1/2 x squared y to the negative 1/2. He is a, I'm going to write this over here. He is a 15y squared dy. Okay, and that says plus. And that equals, and he's negative. Okay, so I just kind of sort of butchered that. All I did was rewrite this one. And I was going to bring this one over, but I wrote it over here. So I subtracted this one over. Now I got to subtract this one over. So I've got a 2xy to the 1/2 dx that is negative because I subtracted it over, plus a 6 dx. So now my dy's are on the left and my dx's are on the right. So remember, if you can't combine it, then factor it out. So I'm going to factor out a dy. That's going to leave me with 15y squared, that's negative, plus 1/2 x squared y to the negative 1/2 equals, I'm going to factor out a dx. Okay, now that leaves me with a negative 2xy to the 1/2 plus 6. So now I've factored out the dy, I've factored out the dx. So now divide both sides by dx, which will give me dy dx. And divide both sides by this chunk. So it'll disappear over here and it will appear over here in the denominator. So I'll have a negative 2xy to the 1/2 plus 6 over a negative 15y squared plus 1/2 x squared y to the negative 1/2. And that is your formula for slope with a tangent line, or your formula for instantaneous rate of change, anything marginal, okay? Anything like that. All right, so let's try it one more time. We have, and we're going to evaluate. So we're going to find an equation of the tangent line to the graph of the function at the given point. So the function I'm given is x minus y minus 1 to the third power, and that's going to equal x. And the point that I'm given is a 1, negative 1. So I've already got my x and my y. I need my m. Okay, so this is going to be my m. Now, you could do x minus y minus 1 times x minus y minus 1 times x minus y minus 1. And then just go term by term, but that's going to be really, really messy. It's going to be messy any way you do it. Okay, so I'm just going to do chain rule. So I'm going to drop my 3 out front. times what's sitting there, drop my exponent by 1, and then times the derivative of the inside. So the derivative of x is 1 dx minus the derivative of y is 1 dy, and the derivative of -1 is 0, okay, equals the derivative of x is 1 dx. Okay, so the issue is I got this chunk, and these dy's and dx's are stuck inside parentheses. So just like we did a few exercises ago, we're going to have to multiply this thing out. So I'm going to take this chunk times dx and this chunk times dy. So that's going to give me a 3 x minus y minus 1 squared dx minus, and then take it times your dy. So 3 x minus 1, x minus y minus 1 squared dy equals dx. Okay, so I need my dx's on one side, my dy's on the other. So he needs to move over. So I'm going to subtract him over. So this stays here. Watch your negative. So I've got a -3 x minus y minus 1 squared dy equals, then I have this. So -3 x minus y minus 1 squared dx plus dx. Remember, there's a 1 in front of there. So plus dx. So I just subtracted this term over. I cannot combine these, which means I need to factor out a dx. So again, I got a -3 x minus y minus 1 squared dy equals, and I'm going to factor out a dx. So dx, and then I've got a -3 x minus y minus 1 squared plus 1. So when you factor out that dx, remember that there's a 1 sitting there, and you factored it out. So your 1 is still there. All right, so divide both sides by dx. So I get dy dx equals this mess over this mess. Okay, so I got a -3 x minus y minus 1 squared plus 1 over a -3 x minus y minus 1 squared. That doesn't reduce, okay? This numerator is 1 more than the denominator, whatever that is. But I do know that I was given a coordinate. Here's my x, y coordinate, and this is my new and improved formula for slope. So wherever there's an x, I'm putting a 1. Wherever there's a y, I'm putting a -1. Okay? So I will have a -3 times 1 minus -1 is 2. Minus 1 is 1 squared. So I've got 1 plus 1 over a -3 times 1 minus -1 is 2, minus 1 is 1, squared is 1. So I end up with a slope of -3 plus 1 is -2 over a -3, which gives me a 2/3. Okay, so now I'm going to flip my page. I have an x coordinate and a y coordinate and an m, so now I can find the equation of the tangent line. So I've got a 1 and a -1 and an m of 2/3. Hold on. Was it 2/3? It was 2/3. Okay. So my m is 2/3. So I've got y equals mx plus b. So my y is -1. My m is 2/3. My x is 1. So I've got a -1 equals 2/3 plus b. So a -1 minus 2/3 is going to be a -3/3 minus 2/3 is a -5/3. So your y-intercept is a -5/3. So you have a final answer of y equals 2/3 x minus 5/3. And that's the equation of your tangent line. Okay? So we're going to do some word problems to kind of sort of apply what we're doing.